Good morning. In today's lesson, we're going to begin solving right triangles. And there are two main cases. The first case is solving a right triangle if you are given one side length and one angle. And this is, of course, in addition to the 90-degree right angle. So here we go. At the top of the page here, I've got the general triangle that we're going to use for this unit. It's consistent with the one that the textbook is using. So you can see here that we are using uppercase letters for the angles and that the right angle is considered C. We're using lowercase letters for the side lengths. And you will find side A, opposite angle A, side B, opposite angle B, and side C is opposite the right angle and is there for the hypotenuse. We're going to be using the rounding chart whenever we write down one of our answers. A reminder of the three main trigonometric functions. These are the ones that we'll be using in the lesson today. Okay, so let's get going with our first example. We are given both side B. It's expressed with 3 significant digits. Notice the little bar over this second zero. So side B is 200 and angle B is 35 degrees. So what I'm going to suggest is that you begin by drawing a quick triangle. I don't do this to scale at all, but I will locate that right angle. And now when I write down side length B, I make sure I look at the picture to note that it is the bottom side. And when I write down angle B, I make sure I note that it is the top angle. So 35 degrees is here. The other thing is when you're solving a right triangle, it means finding 3 unknowns. So I'm going to list the unknown quantities on the triangle. So one angle is unknown, and it's this angle right here. So angle A. And 2 side lengths are unknown. This side length, which is A, and this side length, which is C. Again, lowercase letters for the sides, uppercase for the angles. Okay, I'm going to find angle A first. This is the easiest quantity to determine because we know that in a triangle there are 180 degrees total. So 180 minus the 90-degree angle here, minus the 35-degree angle here, will give us angle A is 55 degrees. Okay, like this. So that wasn't too bad. We've got this angle determined, and now we're just going to determine these 2 side lengths. What I'm going to do to determine the 2 side lengths is use only the 2 given quantities. So I'm going to use this side length and this angle, okay? Because they were given, so we're certain of their answers. We've not done any rounding with them since they are given numbers. All right, so what I'm going to do is simply consider the relationship between these 2 things. Is this side opposite the angle, adjacent to the angle, or is this side the hypotenuse? Okay, so the correct answer there is opposite. This side is opposite that angle. So I'm going to write down the letter O for opposite. Okay, so now when I'm trying to find these 2 side lengths, because of this opposite relationship here, I'm going to choose the 2 trigonometric functions that have the O in them, so sine and tangent. Okay, like this. I'm going to write the sine of 35 degrees equals So sine is opposite over hypotenuse. So here's 35 degrees. Opposite is 200. And hypotenuse of the triangle is side C. So this is now correct. We've said the sine of this angle is equal to 200 over side C. Opposite over hypotenuse, like that. Okay? So now if I rearrange this formula here, you can first picture the C coming over here and multiplying. C times the sine of 35 is 200, and therefore C is going to be 200 divided by the sine of 35. Okay, so with my Casio here, I gotta make sure I'm in degrees, and actually I'm not, so I better fix that. Okay, see, I don't know if you can see it, but there's now a little D here. Okay, to do that I used the mode button, mode. So I made sure I selected degrees. Okay, anyways, now I'm all set. So I'm gonna do 200 divided by sine 35 equals, and I get this answer right here. Okay? Now, it's a side length, so I round it like the other side length, which was given to 3 significant digits. So remember, when you're doing side lengths, you care about the number of significant digits. When you're rounding angles, you care about instead the number of decimal places. So I'm doing a side length, so I want to round my side length to 3 significant digits like this side length, so that'll give me 349. So I write that here. Okay, so that was using the sine function since it involves the opposite side length. So now I'm also going to use tangent because of the O in it again. So we're going to say tangent of 35 degrees is equal to, now I need to do opposite over adjacent. So the opposite side, of course, is still 200. Which side is adjacent to the angle? Side A is adjacent. It's next to or beside the angle. And of course, it is not the hypotenuse. The hypotenuse is always identified because it is across from the right angle. Okay, so again, I did tangent of 35 is opposite over adjacent. So side A is the adjacent side. Okay, we rearrange this so that A is isolated. So again, A first multiplies over here, then we divide both sides by tangent 35. So we end up with 200 over the tangent of 35. Okay, and again, just take out your calculator. 200 divided by tan 35 equals. This is a side length, so we round it to 3 significant digits, so that would be 286. And now the triangle is solved. Notice that for the angle, I kept 1 decimal place, just like the given angle here. Okay, so the question is done when you have your 3 unknowns determined. Now, I never used the Pythagorean theorem at all in the question, so I could use that if I want to check that my answer is reasonable. So I could check that 200 squared plus 286 squared is equal to 349 squared. Okay, so you can always use that as a check of your result if you like. So I'll just put that down for you. If you want to do that, you're always going to be able to check a squared plus b squared should equal c squared. Now, because these are rounded numbers, you know, left side and right side here might not be 100% equal, but equal enough given the rounding that we've done. Okay, let's do a second problem now. A triangle given one side and one angle. So I will set that up on this next page here. So suppose this time we know side C is 17.3 and angle A is 40 degrees. Now I'm going to start with a diagram. Really quick sketch. In the diagram, I start by putting on the two known quantities. Side C, of course, is the hypotenuse, so it goes there. And if you don't remember where angle A is, just look at your general triangle. Angle A is the lower one, so 40 degrees is here. Okay? Now I'm going to label the three things I need to find. So there's one angle I don't know yet, and it's B. And then there are these two sides that I don't know, and they are A is here, and B is here. Okay, so always referring to this triangle when you draw your diagram. Okay, like the last question, we can start by finding angle B, the top angle. There are 180 degrees in a triangle. After we subtract the right angle, that leaves 90. So from the 90, we subtract 40, and we're going to get 50 degrees for angle B. And we keep one decimal place so that it resembles this given angle. Okay, now I'm going to try to find these two side lengths, and in order to do that, I first look at the given angle and the given side and establish the relationship between them. So this side is not opposite the angle. This one is, right? This side is not adjacent to the angle. This one is adjacent to the angle. Rather, this side is called the hypotenuse. So this time we were given the hypotenuse. Remember, in the last example, we were given the side opposite the given angle. This time we're given the hypotenuse. So what does that mean? It means I'm going to choose to use the trig functions with the h in them. So I'm going to choose both sine and cosine. So we set it up like this. We say the sine of the given angle is equal to, now I make sure I do opposite over hypotenuse. Opposite is little a, hypotenuse is 17.3. Okay, so sine of 40 is opposite over hypotenuse. That looks like this. How do we get the a by itself this time? Simply by multiplying. So a is 17.3 multiplied by the sine of 40 degrees. So we'll punch that in our calculator. We're going to round the side like the given side, so 3 significant digits. So 17.3 times the sine of 40 equals, and you can see the answer displayed there. If we round to 3 significant digits, it's 11.1. Okay, the second trig function that had the hypotenuse in it is cosine. So we'll set up a trig function for the cosine of 40 degrees. Now cosine is adjacent over hypotenuse. So here's the angle. The adjacent side is B. So adjacent over hypotenuse ends up looking like this. That side is adjacent to 40 degrees. This side is the hypotenuse. Isolate B using multiplication. So B is 17.3 multiplied by the cosine of 40 degrees. Calculator comes out. 17.3 times the cosine of 40 degrees, and I get my answer. Round it to 3 significant digits, it'll be 13.3. Okay, and that's it. So subtraction and 2 trig functions. Once again, if you wanted to be sure that your answers make sense, you could check, does a squared plus b squared equal c squared? Okay, so I'll just show you that. I could do 11.1 squared plus 13.3 squared is this number, okay? Just very close to 300. And I can compare that to the square of 17.3, right? So very, very close. That means the check worked, okay? The reason it's not bang on, I've already explained, is because we've rounded these two numbers here. Okay, let's do one more together, and then I'm gonna recommend 3 for you guys to try, okay? Okay, one more example. So in the third example, suppose I have A is 125 side A, and angle B is 60 degrees. So let's solve this one next. Here we go, drawing the triangle like this. And then we label the given information. So angle B was the top angle. So 60 goes here at the top. And side A is here. Okay, so again, always referring to this. So 60 is angle B, 125 is side A. What 3 things do we need to figure out? Well, the one angle we need to figure out is the lower one called A. The 2 sides that we need to figure out are B and C. Okay, just like this. Let's start by figuring out angle A. Okay, so it's 180 in the triangle minus the right angle minus angle B, and 90 minus 60 is 30. So angle A is 30 degrees. Just like that. And now we are set to solve for the 2 missing sides. Now, in example 1, I was given a side opposite the given angle. In example 2, the side that I was given was the hypotenuse. What's the relationship in example 3? Here's the angle, here's the given side. That relationship is called adjacent. We were given the side adjacent to the given angle. So I'm going to put A here for adjacent. This, of course, governs which trig functions I'm going to choose. So I will choose the last 2 here because they have the adjacent side in them. Notice that for cosine, it's in the numerator. For tangent, it's in the denominator. So let's set up those functions. The cosine of 60 degrees equals, now I have to write adjacent over hypotenuse. So adjacent is 125. What's the hypotenuse? It's side C. Okay, so solving for side C is going to involve division because the C is in the denominator here. Okay, so we use division. 125 needs to be divided by the cosine of 60 degrees. Let's see what we get. 125 divided by the cosine of 60. Oops. Yeah, it looks like I got 250. So I'm going to write that down for side length C. Now, if I want to make sure I show that it has 3 significant digits, like the given side, I should really put a little bar here. By the way, we only ever need bars over zeros, right? Don't ever put a bar over a non-zero digit. So the only reason we need it here is without the bar, it would look like only 2 significant digits. Once we put the bar there, now we've bumped it up to 3 significant digits. Okay, so we chose cosine because it contained the adjacent side. Remember, the other one that contains the adjacent side is tangent. So we now do tangent of 60 degrees equals, and here we have to write opposite over adjacent. So here's the angle. The side opposite it is B. And the side adjacent to it, of course, is 125. So opposite over adjacent. Opposite over adjacent. Now we're solving for B and it's in the numerator, so this is when we multiply. B is equal to 125 multiplied by the tangent of 60 degrees. (125) tangent 60, and that's 217. Okay, and again, if you like, oops, sorry, I just knocked my camera. Okay, there we go. Again, if you like, you could check your answers by ensuring that the Pythagorean theorem holds true. And again, it would be a check that 125 squared plus 217 squared is 250 squared, or a squared plus b squared is equal to c squared. Okay, and quick talk again about the calculator. If you have a sharp, again, instead of tangent 60, like that, okay, I think you have to do 60 tangent. Okay, it doesn't work on this one, but just keep in mind, if you're not using a Casio, you might, and maybe you have a sharp, I think you have to put the angle first. So to evaluate the tangent of 60 degrees, you would do 60 tangent equals. All right, so keep that in mind if you have calculator issue. And that concludes our first lesson on solving right triangles. This was the case where we were given one side and one angle. I will do another lesson shortly, part 2, how to solve right triangles if you're given 2 side lengths. Okay, as always, I've suggested a few practice problems for you to try from your textbooks. All right, thanks and have a good day.